cloud solution architect with Microsoft, and the area that I mostly focus on is the cloud solutions. That I work with the ISV partners of Microsoft. Um, so welcome to this talk today. It's the cybersecurity track, and we the panel discussion just talked about that what kind of issues you see, what kind of measures you can take to protect your systems and applications. So we are going to take a look at some of the landscape that we have in terms of say cyber attacks, and what are the things that you can do to prepare yourself for. Uh, I mean, preparedness is always a good thing, but then we also have to look at that how we can proactively build a strategy to protect your systems and applications that you're building, right? So we are going to take a look at these two aspects. And then one of the very cool topic that the panel talked about is the security development lifecycle, right? That's a huge topic. Takes a lot of time, but I'll try to basically summarize it as short as I can. And then I'll also share the resources that you can go through after the session to basically understand more and learn more about security. Right. So let's start with some numbers that are there. So there's this company called Hiscox that does the business insurance in the UK, US, and Europe region. So they did a survey last year with their about 5,000 professionals, and the number that they published, which basically says that the 73% of the companies basically fail the cyber readiness tests, right? And then a number of these companies also report the cyber incidents happening. This number was 45% last year, and it has jumped to 61% this year, right? The another publication called Malware Bytes that says, they also do analysis about what kind of attacks people are seeing, the consumers as well as the businesses, and they have predictions, 4 major predictions for 2019. We are already to the towards the end of the 2019, but what they basically see is that the SMBs are going to see a flood of attacks. The second thing that they say is that the APAC region, the Asia Pacific region, is going to see a specific kind of attack, that is region-specific ransomware attacks, and that the third and the fourth are basically related because they also predict that the ransomware attacks against the consumers are going to go down because people are looking at high yield utilizing the same attack, so they are going to target the businesses. So that kind of paints a very grim picture about the security. If you take a look at it, it's not specific to APAC region; it's all across the world, right? So with those numbers, let's take a look at the threat landscape. So these are the prevalent attacks that Malwarebytes and a couple of other security researchers have actually seen in the wild in the year 2018 and 2019. Some of these are simple, and they basically produce a very quick yield for the attackers. Then some of them, like supply chain attacks or the cyber physical attacks, could be a long game for the attackers. Do you guys remember this thing called Stuxnet? Right? That was a cyber physical attack. That's how it started, and it had a very specific goal to basically sabotage the nuclear plants at Iran. And then you have supply chain attacks, right? So you must have also heard about the mobile phone devices that had compromised firmwares installed on them, right? So that gives basically unrestricted access to the attacker that was able to actually compromise the supply chain. Now those are long games. If your mobile phone is compromised, you just imagine you can probably lose your wallet today and survive. But if you lose a mobile phone, it is going to compromise a whole lot of things for you, right? Social networking, your banking information, your two-factor authentication. Some of these apps only work on SMS authentication, right? Which is extremely insecure. So that's what we are dealing with, and that's with the secure phones. Imagine what is going to happen if your phone itself was not secure, right? And then when it comes to the attack surface for these attackers, right? You see, that we are becoming more and more dependent on technology. We have connected cars, we have our mobile phones, we are running cloud applications, SaaS applications, we are running, whatever applications we want on our devices, and these devices connect to our corpnet, the corporate Wi-Fi that you use or corporate network that you have. So each time you install an application, you are basically increasing that attack surface, that your IT guys will have to deal with, right? 10 years ago, when IT wanted to protect a system, all they had to do is basically install, IDS, IPS on the edge, install antivirus on laptops and servers, and that's all. That's done. Today, that landscape has changed drastically, right? You have BYOD, you have cloud applications, SaaS applications, and then the IT doesn't know, what they own and what they don't, but they still have to protect you. You could use applications in which are provisioned by the IT guys, which are sanctioned by the ITs, but you could also use the applications, that you just like, right? Um, there are chat applications, how many of you use WhatsApp to talk to your colleagues? Personal is okay, right? But then you also share business information on WhatsApp. Does your IT approve it? They probably know it, but they can't do anything, right? So that is one example, where it just is extremely difficult for your IT guys to start, protecting the assets that they have, because they don't even know what is the perimeter, what is the boundary here, right? So what it does, and with these, the attacks also keep on evolving. So that basically means, that IT's job is going to be more and more complex every day, and then it is going to contribute towards the rising cost of security, and then ultimately the biggest challenge that the entire world has, that we just don't have enough security professionals to take care of the security requirements of the companies. So this is a very complex problem, and what you can do is just be prepared, and we will talk about that once we move forward. These are the tools that are used that were used in the last year by the attackers in various kind of ways. Python, how many of our Python developers here, right? ML and AI, you basically can't think without Python. Python is also becoming a choice of language for the attackers, right? And then you combine that with the obfuscation, and then it becomes something that you don't understand. You have the source code in front of you, but you wouldn't understand what it is doing. And then we have the backdoors like Evil OS X, Eggshell, Empire. Empire is written in Python. Then you have Metasploit. You heard about Metasploit in the panel discussion, right? It's an excellent security testing tool, but then it also allows the attackers to use it in the ways that are not actually intended, and that happens with a lot of tools. Then we have MITM proxy, which is basically your man in the middle kind of proxy. It is used for web application security testing, right? So if you install it properly, configure it properly, it is useful. But if you leave it not properly configured, it can be basically used to compromise your systems. And then finally, cryptojacking is one of the attacks that we talked about. So XMRig is something that the hackers have used to basically do the crypto mining on the user's laptop without their knowledge, through the adwares and similar ways. But that's just to let you know that what you can actually use, what the attackers have used, and what you can use to fight against them. These are some softwares that I actually found. So these deal with things like static code security, the dynamic security testing, penetration testing, scanning for vulnerabilities, port scanning, basically all categories. And when we come to talk about the security development lifecycle, right, we will see that how some of these tools can be used in various stages of your application lifecycle application development lifecycle. So what it means to basically have your organization ready for security. There are four main tenets of secure development practice that you can build in your organizations. First, you have to start thinking about the design. So design is the phase where you're starting the development. You are thinking about building a product from scratch, right? So what it means that you basically have to start thinking about things like security considerations that are going to be there. You have to start building threat models that applies to your product. You have to understand what kind of third-party libraries or dependencies are going to be used, right? And then you have to start thinking also about how do you educate your developers to think about security when they write code. Can they just pick any library off the shelf and start integrating inside the application, and then it becomes a major technical dependency that you cannot get rid of? That happens a lot, but that should not happen. The security development lifecycle, there's a huge documentation on Microsoft's website. We ourselves follow the SDL methodology, which came out of the Trustworthy Computing initiative that Bill Gates launched in 2002. So that's what we follow, and there's a huge checklist. There's guidance about all of the practices that are encompassed in the SDL methodology, and you can actually take a look at that in the Microsoft website. I'll share the link at the end of this session at the resources. You can probably take a pic, and if the presentation is going to be available on the website, you can also access it. The second thing is, once you're done with this, when we talk about design, right, it's not only doing it one time and just forgetting about it. What you also have to do is, you have to keep on doing these things, at every checkpoint. So things like, your static code analysis, dependency scanning, things like, doing the security tests against your against your runtime, that becomes core part of, how you test your software, apart from, using the right kind of tools and approved third-party libraries. Because when you talk about software development today, right, you don't develop anything and everything in-house. You also depend on a lot of third-party libraries, right? So do you know how many of them actually, follow secure development lifecycle? Are they secure? Do they provide any kind of security audit information to you? And are there any vulnerabilities that are reported against those software? You have to keep a watch on that to understand, whether or not you can use them. And if anything is reported, are they also fixing it quickly enough? Because if they are not fixing it enough, it's not, good enough for you to use inside your application. Because even if you do everything right, somebody else's mistake is going to be your mistake, and then you become responsible for the damage that occurs, right? So that could happen. So you have to keep an eye on that. The next thing is the prevention, right? So the attacks can not only happen against the application, it also happens against the people, right? You have heard about, these terms called phishing and social engineering and so on and so forth, right? So what happens, when you get, compromised like that? So the only way to get out of that is to basically educate, each and every person who's involved, technical or non-technical roles, to understand what constitutes a security threat. And then basically keep an eye on these things, right? And then report it when they see something is not right. It could be as simple as that, somebody's, mobile coming online or trying to access some system, on an odd hour, you might have that visibility. Or it could be as simple as, that you probably detect a login, at a very odd time inside your systems, right? So you don't ignore it. You understand what it is, where it is coming from, and try to report it. And then that also requires, that you get into the mitigation part of the cyber readiness. So mitigation basically says, that you have a security incident response team or process ready. And this process has to be tested periodically to understand, whether there's a gap there or not. It also requires, that you have somebody responsible to handle the security. Because when a security incident occurs, right, it could not be an isolated incident. You will have to basically assess what is getting compromised, what is the extent of the compromise, and then what are the things that are getting compromised. And to be able to understand that, your people will need to have a collaboration and basically collaboration with multiple departments. It could be technical, it could be operations, it could be management, it could also be a marketing, legal, and any other functions that you have. And then the mitigation also means that you need to also plan that when you detect an attack, right? How do you limit the exposure to the things that are actually important? Do you have systems in place that you can use to cut off the access to more important parts of your, say, application or solution? For instance, you have databases, right? Do you have mechanisms in place to basically cut off access to database, without basically redoing the entire engineering? The design phase, again comes in picture there. So you have things like application credentials, you have API keys, right? You have database connection strings. You have SSL certificates, that basically are used to have these two systems, talk to each other over the secure connection, right? How are you storing them? How are you, securing them? I mean, they are used to secure the communication and your application, but how are you securing them? Are you hard coding the application keys inside your application? That's a strict no-no. A lot of people probably don't do that. You probably store them in a variable that you refer inside the application, so that it's not actually inside the code. But then once an employee's credential is compromised and he's able to access your network, he will have access to that information as well, right? So it's not completely secure. How do you protect against those kind of scenarios, right? Are you storing your database credentials, against in similar way? What if network is compromised? What about your SSL certificates? Where is it stored? Is your private and public keys are stored properly, or are they simply available to anybody who can actually get access to your network systems? And when we're talking about this, do you have systems in place where you can also you also have control over what systems can be accessed by what kind of roles inside the organizations? Does your DBA have access to your web servers, or does your web guy do they have access to database servers? and every other combination that there is, right? So that comes to things like, role-based access control. Do you have those kind of functionalities in place? So these are the considerations that you have to think about, and then you have to start developing inside your application development lifecycle processes as well. Detection is probably the simplest part of it. You basically deploy the security solutions which are actually top notch. You get a lot of services. You have things like Checkpoint, F1, and bunch of open source technologies as well to do the detection. And then, once you do that detection, you also have to have all this processes and practices in place to make sure. And then we have, the last component called cyber insurance. How many of you are actually aware of this thing called cyber insurance? Right? That basically says, about the awareness that we have in this room about the security. So cyber insurance is nothing but an insurance product that is also available in India, by the way. Riscox deals with that in the overseas market. And if you're looking for more details on cyber insurance, you can go to Policy Bazaar and search for it. Seriously. So it's that common. So what they do is, when a cyber incident occurs, right, you could have multiple kinds of compromise information. It could be your employee information. It could be your customer information. It could be the data that your customers have trusted you with, and it could have, any other implications. So once that data gets stolen, it could result in, it is going to result in a huge trust loss anyway for your application and for your company, right? But what if there are legal implications for you? So these cyber insurance products actually cover that kind of, deals for you. But that's just the aftermath. Your goal should be to basically not to get into that place in the first place. And how you do that? You basically do that by designing, by putting these practices in place: design, prevention, mitigation, and of course detection. Right? So that's about the cyber security readiness. These are the things that you need to also plan. So it's not a technology problem, it's a business problem as well. So when you talk about cybersecurity, your management has to be aware at every level that these are the things we need to do, and these are the things that are actually needed to make sure that our applications are secure and we are ready to deal with any kind of cyber incident that occurs. And the golden rule of basically the cybersecurity is, that you have to be first prepared. In case something happens, you cannot panic, because panic will not help. You need to have processes and practices in place. And second thing is, when you are in the crisis, you need to have the processes in place to help others. It's not, you cannot have one single person handling the security. You need to have processes and information documented in place and tested so that anybody new who's coming in can also handle the security incident. So that becomes also part of the SDL methodology that we talked about. In the SDL, we have, a bunch of things we talked about this, security trainings, threat modeling, security, jotting down the security requirements, right? And then also building the policies to handle any of security incidents that may occur. And the tools that we talked about, the OSS tools, and also, if you are in favor of any proprietary software, that's also fine actually, but you need to also take a look at the static code and dynamic security analysis done. And of course, the pen test and security testing is a mandatory part anyway. Right, moving on. One of the ways that you can actually one of the ways that the applications are getting deployed are through the cloud, right? And when it comes to cloud, these cloud providers, Microsoft, obviously leads the way there when it comes to the security and otherwise compliance. But then even then, the security of your application is a shared responsibility, right? So you have, you can, deploy your software in VMs. You can deploy your software using, certain managed services, or you can completely go the SaaS route, where you only own the code, but every other service is provided by the cloud provider. In any of these cases, the security becomes a shared responsibility. When it comes to the infrastructure and the services that you're using, the cloud provider owns the responsibility. But when it comes to your application and your code, you have to share the responsibility there. None of the cloud providers are actually going to take the ownership of the security of your product. You cannot expect, a third party to basically own the security in your product if you are not designing your product, in a secure manner, right? So this is basically a very high level overview about what it happens, what the security looks like when you talk about security in a cloud environment. Here are some numbers. So there was one question, I think, from you, what using AI and ML in the security aspects, right? So this is what is the numbers that is provided by the Microsoft Security Intelligent Security Graph. So if you take a look at the product portfolio that we have, Microsoft has, we have Outlook.com, which was Hotmail.com, Live.com, and so many other names. Basically the cloud service. Then we have Azure, we have Xbox, we have Skype, we have Windows, we have Office. These are all, multiple clouds that we have. And these clouds, basically enable us to understand what kind of threats are occurring against what kind of targets. We know that how the individuals are getting targeted, what kind of email attacks occur, how the cloud infrastructure is attacked, right? So that visibility basically gives us a very unique perspective about understanding the security from end to end. And that's what we use to design our products to protect our services and make the platform, really secure for you. One quote, that Satya actually made last year, is very memorable here. Actually, he said that the Microsoft is the biggest security company that nobody has ever heard about. And the context is, that Microsoft spends close to actually over $1 billion every year just on security. Many dedicated security companies don't spend that much amount on their security products. This is, some of the other numbers. So, it basically talks about how AI and ML basically protects the Azure and Office and Windows and Skype and Xbox networks, and some of the success that we have had based on our technologies. And then there are some products that I would like to highlight here, which is Azure Sentinel, which is basically an SIEM software, the Security Incident and Event Management software. So this, and along with the Azure Security Center, is another product, that sits very similar to what you would do with Snort or say Kali Linux or some of the other tools that we talked about in the earlier slides. So Azure Sentinel is an SIEM tool. So what it does, it basically collates the data across all of your applications, whether they are business applications or your cloud applications, or say Office, or applications that are running on the other clouds, and gives you a visibility about the security incidents that are happening across the applications. And then it also has this AI and ML capabilities to understand when should it basically start reporting the data, and then it also gives you the capability to automate the mitigation responses. The next one is the Azure Security Center. So it is basically agent-based software that you can install on the VMs that you're running, whether it's Linux or Windows, doesn't matter. And what it does using these agents, it does the things like vulnerability scanning and gives you, a report about how your infrastructure is protected or not protected. Are you missing any important patches, or should you be applying that? And you can basically take a call to apply those patches then and there. And then the software also integrates, with the other services that we have. For instance, Office is a major software that we have, because when it comes to Office, we also talk about the data protection, right? You have classified documents, internal documents that is stored in the cloud. So the SIEM, Azure Sentinel and Security Center, also allow you to build a secure environment to keep all of your data in single place and protected. There are a bunch of other products that deal with security. So things like, we talked about role-based access, where you should be able to limit the access to certain systems based on the user roles. That is there. You have multi-factor authentication. Azure AD is a centralized identity platform that we have across all the products that we have. That is something that you can also start using inside your applications for, authentication. Then you have services like Key Vault, which allows you to store your credentials, database strings, or say secrets or SSL certificates inside a secure software vault, and then use the software to only fetch it when it is required. So even though people might be able to access, get inside your network, they may not be able to compromise your application, because the Key Vault takes care of that security. And then there are standard services like firewalls and security rules and other stuff. And of course, when it comes to the compliance, there's a list available about the kind of compliance we have across the globe based on the country's requirements and everything. And these were the resources that we talked about. So I think I'm slightly early on my thing. Should have brought in more slides, but that's okay. So the first thing, the numbers that we talked about, the kind of attacks that are prevalent that use open source and closed source, attacks that you can actually check out from the Malwarebytes website. Here's the link. The report is for the Q1. Then the Microsoft Security Development Lifecycle, that's the homepage. It talks about why do you need SDL, and if you want to pursue further, what are the steps that you can take. And apart from that, it also includes a self-assessment tool for you to start assessing what is your stage of security, right? And then you also have a guidance about how you can build a security incident response process inside your company. So that's the last link, which is the SIRR thing, the security incident response readiness. So that's an ebook that you can download to understand what is required to be prepared in case of cyber incident, and then what are the processes and what are the practices you need to have in place to be able to handle it effectively and to be able to protect the critical data even when an incident occurs. So one of the things that you will come across there is to basically reduce the incentives for the attackers to attack you again. You probably will be able to prevent an attack the first time, but how do you prevent it from reoccurring? So that's a learning, and there's a guidance inside the ebook there about that also. So with that, my slides are over actually. If you have any questions, yeah, let's go through them.
So I have two questions here. So, excuse me. So during the panel discussion, one of the member asked that the trust factor between open source and a proprietary tool, right? So and you just mentioned that okay, no matter what software you give, or whether it is proprietary or it's open source, once it reaches to a hacker, they can reverse engineer and then they do it. But most of the cases that we see is when we use open source and it's not properly security tested, those are more prone to attack than the proprietary tools.
Right.
Like we hardly see any of your so that's one part of the question, right? The trust factor, even though we leverage open source, it's reviewed by a community and all, but still the proprietary softwares are well secured because the companies follow a certain standard. The second part of the question is when we move to cloud. So we have the SaaS offerings. So one of your slides shows that when if you can go back. Yes. So on the extreme right side, you see that the user's intervention in securing the application is much less, and the cloud providers is much more. So can you throw some insights that how would a SaaS application be secured?
Okay. So so like you said, I kind of agree and disagree with some of your points actually. So for instance, we talked about open source software not being configured properly, which can result in more security issues, which is absolutely true. But that can also happen with the proprietary software, because they just provide you the software, and you still have to have expertise to basically deploy them properly in the right ways. So that's where one of the tenets that we talked about in the cybersecurity readiness is the basically employee training, right? The training basically talks, makes everybody aware in the organization about that what are our security requirements and how you should be going about configuring any software. So once that awareness is in place, right, that's when you can take any software and people will know that they have to configure it properly, right? One of the trainings, one of the things that we go through in Microsoft about the security is to basically understand what are the security configuration in given software, right? So one of the examples was Apache, right? If you don't configure it properly, it could basically give access to people. So those things have to be there. And when we talked about the security requirements, that basically means that you need to know what tools are actually permitted to be used inside the organization. And when you have that shortlisting done, you can also build customized training to make people aware that this is a strictly no when you're trying to use this software. So training and awareness basically plays a great role in making sure that your environments are actually secure, right? So education is obviously that thing. And when it comes to the second part of your question actually, right, so you can take Apache software. Let me take the same example again. So you can install Apache on a VM, right? But that only means that you're taking the basic component that any cloud provider gives you today. What it means that you create a virtual network, you create a VM, you create username passwords, you can choose to expose the SSH port out in the world. Same goes for Apache. You can probably run your website on port 80 without any SSL certificates, without any security. So that basically leaves you to control the entire aspect of security, right? Because you are responsible. You got a VM, you installed some software, you configured it, and then you're running it. So which basically means that we have no visibility, right? As a cloud provider, it's probably true with all the cloud providers, but I can say for sure in Microsoft that we don't know what data you're actually storing inside your subscription, how you're configuring your VMs, or how your VM, or what kind of software your VM is running. When you open a support ticket, right, the support engineer has to work with you to take a look at inside your VMs. We only have the visibility to the operational specs of the VM, right? What kind of traffic is coming? Is any malicious IPs trying to access this VM, or is some traffic going is some traffic going out of this VM can be classified as malicious. We do that kind of thing, but we don't understand. We don't have a visibility what you're doing inside your application and software inside the VM. So that's where if you see the maximum onus of security is on you when you talk about the basic IaaS kind of environment. It is comparable to on-prem as well. But when it comes to SaaS, we actually provide you everything. Your computing is provided, your networking is provided, your software is pre-configured for you to just deploy your code. So that environment leaves you with the responsibility to only make sure that your code is running securely, your application is designed securely. And that's why you see that your responsibility when it comes to SaaS based products which is running on the managed services is actually extremely low compared to what you would have otherwise if you run the software on the IaaS. One of the points that Malwarebytes talks about when it talks about the SMB being under a flood of attacks in the year 2019, they say that the only way to prevent it is to actually basically use the managed security providers to make sure that the systems are actually running as secure as they can.
So if I may, I can have one follow-up question. So it's generic to not only to Microsoft, so it's generic to all the cloud providers. So basically, so if I spin up an IaaS, take an IaaS subscription and spin up my services on it, and once I find an intrusion, so I see somebody is attacking. So the application developers or the service team may not be well equipped to stop it. So does the cloud providers give us some capability to stop the traffic?
Yes, I mean I'm not sure about what AWS and Google do, but in Microsoft we had this. So one of the things that I would like to highlight here is the Azure Security Center can actually prevent certain kind of attacks when they happen. Brute force is actually one of them, and it generates an event which can basically go into Sentinel, and then you get a larger visibility about what was happening. But then there are this bunch of other services, right? So Security Center is something that you can use to basically understand the intrusion occurred and it was stopped. But then you also have Sentinel, you also have the firewall, Azure Firewall as a service that you can actually use. But that's about it. But then Microsoft being a partner-oriented company, we also have a bunch of these partners that also provide, who are actually dedicated security companies, right? So they also provide the software to give you that capability to protect your infra.
Thank you.
Thanks. All right, thank you very much. I will be there at the Microsoft booth there at the entrance. So feel free to come and have a talk about security in case you have any more questions. Thank you very much.